Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to physics class. Today our topic is about standard form or scientific notation. The first question is, what is standard form or scientific notation? So, it is a way of writing numbers that are too big or too small to be easily written in decimal form. Uses. It is commonly used by scientists, mathematicians, and engineers. In physics, we deal with numbers that are either very small or very large. It becomes difficult to write these numbers. So, for example, if we talk about very large number, so we take the mass of moon, which is approximately, the value is given, it is in kilogram. And sometimes we have very small number, that is the diameter of atomic nucleus is about the value, which is this meter. Clear? So these type of values, in written form it is very difficult to write these type of values. So for this greater values, we have the specific formula for writing these greater and smaller values, and our formula is n equals to m multiply 10 power n. Now here n, it is the given number, and it capital M, it is the mantissa, and 10 power small n, this n show the exponent or the power. So n is given number, m is mantissa, and n is exponent. Now there are different steps for converting the number to standard form. For example, in a given number n, move the decimal point and place it after the first non-zero digit, which will make it mantissa m. Now second, if the decimal is moved towards left from its given initial position, then the power of 10 will be positive, and whatever is the number of digits through which the decimal point has been moved, that will be the value of exponent power of 10. In the next point, similarly, if the decimal point is moved towards right from its given position, then the power of 10 will be negative, and whatever is the number of digits through which the decimal point has been moved, that will be the value of exponent, the power of 10. So, these are the three rules for converting the number into standard form. For example, number 1, we have a value 456,000. So, if we convert this value into its standard form, so it can be written as 4.56 into 10 raised to power 5. How it will be possible? When we have the larger value, so suppose that there is a decimal at the end of every greater number. So when we talk about this greater number, so here we move from right to left. So here we count 1, 2, 3, 4, and 5. So decimal always shift after first non-zero digit. So it is 4 is the non-zero digit. It is first non-zero digit, so 4 is the first non-zero digit. So here the decimal is put after 4, so it will be 4.56 into 10 raised to power 5. Now we have a very smaller value, that is 0.0000234. It can be written as, here the decimal is already present, which will be shift also after the first non-zero digit. So here in this value, the first non-zero digit is 2. So decimal will be shifted after 1, 2, 3, 4 and 5. So here we move from left to right. So our exponent will be minus, negative, minus 5. And in this value we move from right to left. So our exponent will be positive. Clear? In this second example, we have, for example, this greater value. So here it can be written as, in greater value, as I have told you that there is a decimal place after the last digit. So we move from here 1, 2, 3, 4, 5, 6, 7, 8. So we know that 7 is the first non-zero digit and our decimal will be shifted from right to left. So it will be placed after the 8 digits. So our exponent will be 8. Our value will be 7.87 into 10 raised to power 8. So exponent will be positive. Now, if we have the smaller value, that is 0.0000000387, so it can be written as, here decimal will be shift after first non-zero digit, that is 3. So it will be 1, 2, 3, 4, 5, 6, 7 and 8. So it is 3.87 into 10 raised to power minus 8. So exponent will be negative because we move from left to right. So I hope that from these two examples you will clear about the standard form or scientific notation, that how we will convert the greater or smaller value into standard form. In your book, the examples which is given, that is the mass of moon, is approximately this. Here this greater value is given, this kilogram. So when we convert this greater value into standard form, so the decimal is placed after the last digit. So here we shift from right to left. So our decimal will be shifted after the first non-zero digit, that is 7. So it will be 7 into 10 power 22 because we move from right to left. So exponent will be positive kilogram. Similarly, when we have the diameter of atomic nucleus is about that 0.00000001 meter, so it has the smaller value. So our decimal will be shifted from left to right and it will be placed after the first non-zero digit, that is 1. So it will be 1 into 10 raised to power minus 14 meter. Now, how to convert a large number into scientific notation? We have these other examples. If decimal is shifted to left, so exponent will be positive. Again, you have this. So decimal is placed after this value. So it will be 1, 2, 3, 4, 5. So exponent will be 5 and plus 5 because we move from right to left. In this value, also we have the decimal in the last. So we move after the first non-zero digit and our exponent will be 8. Count here 1, 2, 3, 4, 5, 6, 7, 8. Similarly, in this value, it will be 1.0 into 10 power 6. Clear? So therefore, we convert a large number into its standard form and decimal is shifted to left and exponent will be positive. Similarly, how to convert a smaller number into scientific notation? Now here we have already decimal which is placed here in the value. So it will be shifted from left to right and it will become 5.3 into 10 raised to power minus 3. The exponent will be negative because we move from left to right. In this example, we also move from left to right, so our exponent will be 1, 2, 3, 4. 7.83 into 10 raised to power minus 4. Similarly, 0.0000457, so decimal always put after first non-zero digit and it will be minus 5. So, decimal is shifted in to right, exponent would be negative. So, hope that it's all clear to you about the standard form or scientific notation. Now we come to the prefixes. Next topic. What is prefix? Prefix are the words or letters added before a unit because pre means before. So, the letters or words which added before a unit and stand for the multiples or submultiples of that unit such as kilo, centi, milli and micro. For example, we have a standard unit that is meter. So, we write kilo before the meter, kilometer, then centimeter, then millimeter, then micrometer. So, these are all the prefixes. What is the requirement of prefixes? Some quantities are very large and some are very small. For example, we have these values. Now, it is very large, it is small, it is again very small values, so etc. There was a requirement, a easy way to express such type of quantities. SI unit fulfill this requirement by their multiples and submultiples, expressed in terms of prefixes. So we can define these prefixes as a mechanism through which a very large or very small number is expressed in terms of power of 10 is called prefix to the power of 10. For example, the thickness of a paper can be written conveniently in smaller units of millimeters instead of meter, and the distance between two cities can be expressed in bigger unit that is kilometer. Now, we have a table in which we show the prefixes that the words or letter added before SI unit, kilo, mega, giga and milli. So, the detail is given in the table, that is, we have exa 10 power 18 represented by E, peta 10 power 15 capital P, tera 10 power 12 capital T, giga 10 power 9 capital G, mega 10 power 6 capital M, kilo 10 power 3, hecto 10 power 2, deca 10 power 1. Then we have deci 10 power minus 1, centi 10 power minus 2, milli 10 power minus 3, micro 10 power minus 6, nano 10 power minus 9, pico 10 power minus 12, femto 10 power minus 15, atto 10 power minus 18. So we have these different types of prefixes. Now what are the limitations of prefixes? So remember, one prefix can use with a physical quantity. Double prefixes cannot use with one physical quantity. Example, no prefix can use with kilogram because kilo is already used with gram. So, when convert the low prefix to high, divide by the multiple of that prefix. For example, meter to kilometer. So, divide by 10 power 3 or 1000. Now, if you want to convert the higher prefix to lower, multiply the multiple of that prefix, that is, multiply by 10 power 2 or 100. So, these are the different limitations for prefixes. Multiples and submultiples. For example, these are the example of multiple and submultiple: kilo 10 power 3, centi 10 power minus 2, milli 10 power minus 3, micro 10 power minus 6, nano 10 power minus 9, and same is meter, that is the standard unit. and these are the multiples or submultiple. What are the advantages of the prefixes? Prefixes are very useful to express very large or small quantities. For example, if we have 20,000 gram, so it will be converted as 20 into 10 power 3 gram. Or you can say that here the 30 convert into 10 power 3 and then 10 power 3 convert into kilo. So it will be 20,000 gram equals to 20 kilogram. Similarly, we have 0.005 meter, so it will be converted into standard form by 5 into 10 power minus 3 meter. So the value of minus 3 is milli, so it will be 5 millimeter. Similarly, in this figure, we have 3, 300, 000 hertz. So here we convert this value 3300 and then it is 60. So it will be 10 power 6 hertz. Now 10 power 6 equals to mega. So it will 3300 megahertz. Clear? Now these three values, when we convert this in standard form 3.3, now it will be 10 power 9 hertz. Clear? This is 10 power 9 hertz and 10 power 9 will be written as giga. So it will be 3.3 gigahertz. So I hope that these examples will be clear to you. For example, here we have 0.0002 gram. So the decimal will be shifted after first non-zero digit, that is 0.02 into 10 is power minus 3 gram. Clear? Now 10 power minus 3 equals to milli. When we convert this 0.02 milligram, now 0.002 gram, 1, 2, 3, 4, 5, 6. Now it will be 10 power minus 6 gram. 10 power minus 6 equals to micro. So it will be 20 microgram. 5000 gram. So 30 convert into 10 power 3. So it will be 10 power 3 equals to kilo. So it will be 5 kilogram. Similarly, these 6 zeros convert into 10 power 6 and 10 power 6 equals to mega. So it will be 2 megawatt. Similarly, 225 into 10 power minus 8 second. So 2.25, its standard form is 2.25 into 10 power 2 and then it will be 10 power minus 8. So 10, 2 minus 8 equals to minus 6 and minus 6 equals to micro. So in this way we convert the prefixes into one to other form. So I hope that these all topics are clear to you. Till the next class, Allah Hafiz and take care.